you can use numbers to count things in the world. So, for example, you can talk about the number of planets or the number of Galilean moons of Jupiter, which is one of his examples he talks about. So you can say the number of Galilean moons of Jupiter is 4, but you can also use numbers to count numbers. So just as you can say the number of Galilean moons of Jupiter is 4, you can say the number of prime numbers less than 10 is 4. So you can say the number of prime numbers less than 10 equals the number of Galilean moons of Jupiter.
Right.
So the fact that you can count moons of Jupiter, which are objects, and using just the same numbers, you can count numbers, Frege thinks the only way to explain that would be if numbers were also objects, so also belonged in the widest possible logical sense to the same logical category as moons of Jupiter.
Well, hello, everybody, and welcome to the second of our Frege interviews with Professor Michael Potter. So in the first interview, we talked primarily about Begriffsschrift and some biological things about Frege. And we looked at the most important paragraph in philosophy, where Frege talks about ways that we can, through substituting parts of natural language, begin to structure sentences, and how that unified to previous kinds of logic, the Stoic logic and the Aristotelian logic. So if you haven't listened to that yet, I'll put a link in the description. Have a listen to that first, and then come back to this one. But today is going to be all about Frege's second book, The Foundations of Arithmetic, often known by its German title of Grundlagen. And we're going to spend the entire time talking about that. So rather than tell you too much about what's going on in this interview, well, maybe I will. We're going to be looking at Frege's overall project and how he begins it in that book, the project of logicism. We're going to look at Frege trying to approach some philosophical questions around logic and mathematics, such as, what are numbers? How do we know about them? That kind of thing. And then some other famous problems that he tried to tackle, such as the Julius Caesar problem. And then after this, we will, at a later date, have a third interview where we'll look at the rest of Frege after the Grundlagen. We're going to look at the basic laws of arithmetic, Russell's paradox, the sense-reference distinction, and bits to do with thoughts from his final series of essays, Logical Investigations. So all that to look forward to. Subscribe to know when that comes out. And then you'll know almost everything there is to know about Frege. Not really, but good enough. Okay, great. So thank you again for joining us, Michael. Well, let's start with the book itself. So the Grundlagen. So what led to its publication? What's Frege trying to do in there? How does it fit with his career?
He published in 1884, so 5 years after Begriffsschrift. So if you remember from last time, we were saying that Begriffsschrift is the work in which modern formal logic was born, this subject where you can study the relationship between the scopes of various expressions using quantifier and variable, which Frege introduced into the subject. And in Begriffsschrift already, Frege had a goal in mind. He didn't just decide to found modern logic for the fun of it. He founded it with the project in mind of using his Begriffsschrift, his conceptual notation, to as an underpinning for arithmetic. So he already in Begriffsschrift had this idea that arithmetic could be written in logical notation, and had the project of showing that once you've written arithmetical sentences, rewritten them in this logical notation, they could be proved, so they would turn out actually, therefore, to be translatable into logical truths. So that was already his project. And then what he did in 1884 was he published this informal book with hardly any symbols in it at all, in which he tried to make this project plausible. So he doesn't complete the project in Grundlagen. He hopes to come back and produce a fuller technical book later, which will, he thinks, justify this project. So all he's doing in Grundlagen is the informal, more philosophical, less technical work of trying to make his overall claim that arithmetic is part of logic plausible. And part of the reason why he wrote Grundlagen in this much more accessible style, without symbols, was that he had been disappointed with the reaction to Begriffsschrift, or the lack of reaction to Begriffsschrift. And so he'd written to a friend of his called Stumpf, and Stumpf replied, and I'll just read this out. Stumpf said, "With regard to your work, to which I'm looking forward with extraordinary interest, please do not take it amiss if I ask you whether it would not be appropriate to explain your line of thought first in ordinary language, and then perhaps separately or on another occasion in conceptual notation. I should think that this would make for a more favourable reception of both accounts." So Stumpf is recommending him to try to make his work more accessible, to write a book that doesn't require this rather rebarbative formal notation. Mm-hmm. And Frege seems just to have taken that advice and written the book. And the result is, Grundlagen is a delight to read. It's one of the most enjoyable books I know of in philosophy to read. It's written in a very accessible style. It shows Frege at his most accessible, and it's actually rather uncharacteristic of the rest of Frege, because you get the impression that Frege is quite enjoying himself here, whereas I'm afraid in quite a lot of his other work, especially his later work, he becomes rather kind of passive-aggressive towards other people. He's constantly criticizing people, whereas in Grundlagen he does criticize other philosophers, but there's an overall lightness of touch to it. So it doesn't come over as just bad-tempered in the way that some of his later work does.
Okay, great. So if he's not trying to take a technical route and use technical notation to prove maths comes from logic, what kinds of things is he trying to sort of argue for or show in Grundlagen if it's not of a technical nature?
The overall idea is that he wants to make it plausible to the reader that arithmetic is part of logic. And the way he does that is that he looks at other accounts people have offered of what kind of truths arithmetical truths are, and he shows for each of the other accounts on the market why they don't work. So he takes empiricism, the idea that arithmetical truths are basically just empirical generalizations, and he tries to show that that doesn't work. And he also looks at psychologism, the idea that numbers are mental entities and that arithmetical truths are psychological facts about us, and he tries to show that that doesn't work. And then he has this key idea, which is that there's something distinctive about arithmetical truths, which is their wide applicability. So he thinks that what's noticeable about an arithmetical truth, like 7 plus 5 equals 12, is that you can apply that truth in arguing about absolutely anything. In particular, he thinks you can apply that in arguing about non-empirical things. So you can use 7 plus 5 equals 12 to argue about apples and oranges. You know, I've got 7 apples, I've got 5 oranges, therefore I've got 12 pieces of fruit. So I'm there using an arithmetical truth to deduce something about empirical things, apples and oranges. But I could also, he thinks, use an arithmetical truth to argue about I don't know, angels, for example. So things which aren't empirical. And Frege thinks that fact, as he claims, if it is a fact, what Frege claims, that you can use arithmetic to argue about absolutely anything, is a clue, because he asks, well, where else have we come across a kind of truth that you can use in arguing about absolutely anything at all? Answer, logic. It's the distinctive feature of logic that you can use logic to argue about absolutely anything. So, other subjects, there are other subjects where we have knowledge, like physics or economics or whatever. Each of those has a distinct has a subject matter. So you can use physics to argue about atoms and electrons. You can use economics to argue about interest rates and unemployment. So each has its distinctive subject matter, whereas logic doesn't, in that sense, have a distinctive subject matter. It doesn't have limitations of that kind. You can use it to argue about absolutely anything. He thinks arithmetic you can also use to argue about absolutely anything. Therefore, he thinks, isn't it plausible? The explanation for that is that arithmetic is part of logic. That, if that's right, that would be a neat explanation for its absolutely general reach.
So, Michael, I noticed that you're talking about Frege arguing here for arithmetic being related to logic because of its universality.
Yeah.
But it seems that other features of mathematics, they all have this universal aspect. So, I mean, geometry seems to apply to everything. It doesn't, anything in the empirical world, at least, we might seem to think.
Quite. I mean, geometry applies to everything spatial.
Right.
But I guess things like God and the angels are supposed to be non-spatial. Also, Frege has an argument to say that another feature of geometry is that, at least for the purposes of conceptual thought, he says, you can entertain the possibility of a geometry that's different. So Frege's views about geometry are quite curious, because he does seem to have thought that Euclidean geometry was privileged as being the geometry of space around us. But he recognized that he was aware of non-Euclidean geometry. So that's geometry where space is curved in a certain way, so that the angles of a triangle no longer add up to 180 degrees as they do in Euclidean geometry. He was aware that mathematicians study that. I mean, he himself studied geometry in his doctoral work. So he knew about non-Euclidean geometry. So he knew that, at least conceptually, we can think coherently, consistently about a non-Euclidean geometry. What he denied was that could be the geometry of actual space. He thought that the geometry of actual space, he seems to have thought that the geometry of actual space was Euclidean. But he thinks that is a distinction, that is a place where you can draw a distinction with arithmetic. So he thinks you can consistently conceive of a kind of possibility where space doesn't have the properties that he thinks space does have, such as that the angles of a triangle add up to 180 degrees. But he thinks that there's no corresponding notion of a non-Euclidean arithmetic. He thinks that as soon as you try to deny any arithmetical law, things fall apart, complete confusion ensues. So he thinks that that's a way of drawing a line between arithmetic and geometry. Geometry has a consistent alternative, even if he thinks that alternative isn't realized in the actual world, whereas arithmetic, he thinks, just doesn't have, in that sense, a consistent alternative. If you tried to use an arithmetic where 7 plus 5 equals 13, he thinks you would just get into an intellectual mess. You wouldn't be able to make progress.
Right. Okay. So arithmetic is logic. Geometry is not necessarily. He's not concerning himself with geometry. What about things like algebra or stuff of that sort?
He doesn't say. He doesn't. Perhaps partly because he was clear that he thought geometry wasn't part of logic. He certainly wasn't ever tempted by the kind of logicism that Russell adopted a few years later, where Russell's project was to develop a theory that was part of logic and that you could use for all of mathematics. Frege wasn't tempted by that project, presumably because he thought geometry was part of mathematics, geometry wasn't part of logic, therefore general logicism about mathematics, Frege thought, wouldn't work. So the result of that is he never really talks much about other areas of mathematics. He just doesn't seem to have been interested in them, I guess.
All right. Okay, great. So he's right. Let's just remind ourselves where we're at. So he's written the Grundlagen to make the logicism project, which is to demonstrate arithmetic is part of logic. And he's wanting to do it in non-technical ways. So what sort of things does he try to do? What kind of questions does he have to try and answer in a philosophical way then to make it plausible?
He has to reject other accounts. So, for example, he rejects psychologism. Mm-hmm. So he rejects the idea that arithmetic is about an aspect of the mental. The reason he has for that is that he thinks that that can't explain the objectivity of mathematics. So if the number 2 was an idea, then he thought that would make it private to me. My ideas are mine, your ideas are yours. You can't have my ideas. So if my number 2 is an idea in my mind, your number 2 is an idea in your mind, then your number 2 isn't the same as my number 2. So if I tell you that 2 plus 2 equals 4, then you can't grasp the truth that I'm trying to express, because my truth is about my number. So he thinks that psychologism leads to solipsism about arithmetic. It would make my arithmetic incommunicable to you. He thinks that's just obviously wrong. He thinks that we do have a common stock of arithmetical knowledge. And following on from that, given that he thinks that that's an argument against psychologism, he then adopts the so-called context principle, which is that only in the context of a sentence do words have any meaning. Now, the reason he thinks that that principle, the context principle, is important to his project is he seems to think that only if you agree with the context principle will you be able to get out of the rut that psychologism gets you into. So his thought is that if you think that number words, like 2, 3, 4, and so on, if you thought, contrary to the context principle, that they had meaning on their own and not merely in the way that they contribute to meanings of whole sentences, Frege thought that if you made that mistake, you would find yourself with no alternative but to think that the number 2 referred to something in your mind, because what else can it refer to? So the idea is the context principle, he thinks, is a defense against psychologism. So his idea is, yes, if you focus on number words on their own, sure, you might be tempted by psychologism, and that would be a mistake. So the trick is, don't focus on individual number words, look at whole sentences. So he reconfigures the project of the philosophy of arithmetic as not so much being about what the individual words refer to, but look at the whole sentences and explain the role of the whole sentence. So look at a whole arithmetical truth like 7 plus 5 equals 12. If you can get an account of that, of the whole sentence, he hopes that the individual words may to some extent take care of themselves. I mean, to what extent we may want to come back to later, because there's the difficulties there, but that's the general idea. So the context principle is quite striking. In particular, it's being used most famously by Michael Dummett in his exegesis of Frege. At least on Dummett's reading, the context principle is the most significant thing in Frege's philosophy. So, I said that I thought the most important bit of Frege's philosophy was Begriffsschrift section 9. Dummett thinks, or thought, that the most important thing in Frege's philosophy was the context principle. I mean, Dummett makes a big deal of the idea that the context principle is, in Dummett's view, the moment when analytic philosophy is born, because it's the moment of what he calls of the linguistic turn, the idea that you thought you were asking a metaphysical question about what numbers are. The context principle reconfigures that as a question about language, about what's the contribution that number words make to the meanings of whole sentences. So it puts the theory of meaning and philosophy of language at the center of philosophy, rather than putting metaphysics at the center of philosophy. So it turns things round, as it were. And so on Dummett's reading, modern philosophy, as it was practiced in the 20th century, all flowed from this moment in 1884 when Frege publishes the context principle.
Right. So let me just make sure I'm understanding the implications of what you're saying. So the idea would be that, well, naturally, we might assume that the meanings of sentences are somehow constituted by the words that are in them, that the meaning of grass is green is constituted by the meaning of grass, and the meaning of is green. And so first of all, we might think that meaning is something to do with what those words refer to out in the world, the grass thing out there and the greenness that's out there, maybe. But if you have the context principle, then you say, no, we need to understand the meaning of things like grass and greenness in terms of the sentences in which they are a part, all the different sentences that involve green and all the different sentences that involve grass. And that this then means that we don't ask what a number is, what the number 2 is. We ask, what role does it play in the meaning of what we say in math? So this is the idea then to say, well, at least on Dummett's reading, that analytic philosophy is born when we start to ask about the meanings of things rather than the nature of objects out in the world. Or at least we start with that question.
Yeah. So the case for which the context principle seems most plausible is the case of a term for a universal. The case for which it seems least plausible is that of a term for a particular. So if I say, Socrates is mortal, then Socrates, therefore, there is a name for a particular philosopher. Mortal is a name for a universal, mortality. What is it to understand each of the words Socrates and mortal? Well, you might think it was pretty plausible to say that your understanding of the word mortal, it doesn't come on its own. We don't understand mortality on its own. We understand what it is to ascribe mortality to individuals. So if you want to test a child to see whether they've got the concept of mortality, you can't say, well, point to mortality for me. You have to talk to them and see if they can use the word mortal in whole sentences in ways that cohere. And there's a certain point in talking to them that you think, yeah, this child understands what mortality is.
Mm-hmm.
Whereas in the case of terms for particulars, a lot of people are more resistant to the context principle. I mean, for example, Peter Geach, famous 20th century philosopher, he thought the context principle was just wrong. for proper names. He thought the context principle should only be applied in the restricted case to things like concept words, like mortal. And the reason people like Geach think that is that they think that you can grasp the meaning of a proper name on its own. So do I grasp the name Nathan? Yes, you're Nathan, right? So the thought is, you can test me on my understanding of the word Nathan independent of all sentences. I just point and go, Nathan. Now, the argument against that, if you're going to defend Frege, is to say that it isn't a complete test of my grasp of the word Nathan if I can just point and go Nathan, because if it's the case of the child where you're checking up on whether they've grasped the word properly, just being able to point isn't enough. So first of all, you need to know when, not just now that that's Nathan in front of me, but the next time I meet you, I need to be able to reliably name you Nathan again. And also, and part of that is, I mean, the way Frege puts it is, it's to do with identity conditions. You have to have a way of telling when it's the same object again. And the other part of that is, just being able to point isn't enough, because I need to know what I'm pointing at. So the point is that what the word Nathan refers to isn't just the shape that looks like that on my screen at the moment. It's the person, right? Nathan is the name of a person. So the identity conditions associated with the word Nathan are an instance of the identity conditions for people. So we have identity conditions. We have, I mean, exactly what they are, of course, is a big issue in philosophy, but of personal identity. But all of us, even if we haven't done a philosophy course, can operate reliably in most ordinary circumstances. Unlike other than circumstances where half your brain's been scooped out and put in someone else's head, in which case I might be unsure which one was Nathan. But in ordinary circumstances, I'm pretty good at tracking which one counts as the same human being. So the point is, what all that shows is that the word Nathan doesn't have a meaning on its own. The meaning of the word Nathan has to be understood in rather complicated terms to do with identity conditions. And the way that Frege puts that is that I have to be able to use the word Nathan in whole sentences.
Yeah. So does this mean, because so obviously with the case of and something we can see, like myself, it seems quite natural to think we understand those names by pointing. But obviously, if Frege's sort of primary concern is numbers and arithmetic, then you can't point at numbers. And so if he says that, well, we actually need to first of all start to look at terms in the context of the sentences in which they appear. Does this mean that he's sort of not drawing a hard and fast distinction between numbers and objects like books, etc., because both must first and foremost be understood in terms of sentences?
He's drawing one kind of distinction between numbers and books, but not another kind of distinction. So one of the distinctive features of the account he offers in Grundlagen is that he has this notion of an abstract object. So numbers, he thinks, are like books or people in one respect, namely they're objects, but unlike people or books in that they're abstract, not concrete. So take that in two parts. First of all, the abstract concrete distinction. He thinks that numbers are not what he calls wirklich, which is the German word for from the same origin as Wirkung, German for an effect, so an action. So numbers are not causally efficacious. Okay, so not being wirklich means they're not part of the causal nexus. They don't, you can't knock something over with a number the way you can knock something over with a book. So that's the difference between numbers and empirical objects, that they're not wirklich, not actual, not concrete. But the similarity, he thinks, is that numbers are objects. Now, this is the point at which things get a bit tricky, because it turns out that this claim that numbers are objects is going to be really important for the technicalities of his work. But he gives very little justification for it. So his thought here is, one of the interesting features of number words is that in ordinary language, they actually function both as nouns and as adjectives. So you can say the number of books on the table is 2. There, the word 2 is functioning as a noun.
Mm-hmm.
Or you can say there are 2 books on the table. There, the word 2 is functioning as an adjective. Now, number words aren't unique in that, having that dual role. For example, colour words have the same feature. You can use the word red in both those ways.
Mm.
But then, so you've got 2 uses, as a noun, as an adjective. And then the question is, which of those 2 uses are we going to regard as fundamental? I mean, we're going to want to have some kind of account where one of the uses is explicable in terms of the other. And what Frege does is he points out that whenever you've got a use of a number word as an adjective, you can rewrite that sentence so to convert it into a sentence where the number word appears as a noun. So there are 2 books, you rewrite as the number of books is 2. And then Frege just kind of slips it in. From then now he's going to treat the noun use as the basic one and the adjective use as the derivative one. And the reader thinks, hang on, why? Don't you need an argument to show that it has to be that way round, not the other way round? Now, Frege has a bit of an argument why it should be that way around. Part of that is just his technical project just wouldn't work if it was the other way around. But another part of it is that he thinks that you can use numbers to count things in the world. So, for example, you can talk about the number of planets or the number of Galilean moons of Jupiter, which is one of his examples he talks about. So he can say the number of Galilean moons of Jupiter is 4. But you can also use numbers to count numbers. So just as you can say the number of Galilean moons of Jupiter is 4, you can say the number of prime numbers less than 10 is 4. So you can say the number of prime numbers less than 10 equals the number of Galilean moons of Jupiter.
Right.
So the fact that you can count moons of Jupiter, which are objects, and using just the same numbers you can count numbers, Frege thinks the only way to explain that would be if numbers were also objects, so also belonged in the widest possible logical sense to the same logical category as moons of Jupiter.
Yeah.
So that's the nearest you get to an argument in Grundlagen, I think, that numbers are objects.
Yeah, and it would also seem that if he can show, which he tries to, that any adjectival use of numbers can be converted into a noun use, but that the reverse was not the case. I mean, 2 + 2 = 4 can't be converted into an adjectival use because, as you said, it generally applies to anything. So it's not 2 angels plus 2 angels = 4 angels. It's just 2 + 2 = 4. So, I mean, obviously for a mathematical project, you'd need, if you were going to reduce it one way or the other, it seems to be reduced to objects.
If you want to preserve mathematics as it's standardly practiced, Yes. However, Frege doesn't try seriously to develop arithmetic thought of as adjectival. He has an argument why the adjectival account won't work if you grant the numbers are objects. That's the so-called Julius Caesar argument. But that's to grant the point that we're currently discussing. If you were someone who didn't yet accept that numbers are objects, if you thought the primary use of number words was adjectival, as I say, there would be some things you would then be struggling to explain. You would then struggle to explain how we can count numbers, for example, and there would be other bits of mathematics that you might struggle to explain. But ordinary uses of number words in ordinary language, you can get a long way with treating the adjectival use as primary. So I do think that in the argumentative structure of grundlagen, I think this is a gap. I think he doesn't give enough attention to justifying this core key assumption that numbers are objects.
Okay, great. So we've got the fact that numbers are objects of Frege by their role in sentences, but also by reducing one kind of role they have in sentences to another. But how does he sort of explain what a number is, like the nature of a number?
Okay, well, the next step in his analysis is he asks, so suppose you grant that numbers are objects, how are they used in language? The answer is we use numbers to count stuff. What does it mean to use a number to count stuff? Well, Frege thinks it's important for us to be clear that we can't count stuff. We have to count stuff under a concept. So if I just give you a pack of cards and just ask the question, how many? So I just give you the pile and say, how many? Frege thinks that question so far isn't well posed, because I might be asking you how many cards in the pile I gave you, or I might be asking you how many suits. So which is it? Is it cards or suits? Or is it, I might be asking you how many face cards or whatever. So the point is, just giving you a pile doesn't yet determine the number. We need a concept so that you now know what you're counting. So you know you're counting suits or you're counting cards or whatever. So his core, put those two ideas together, and he thinks the core use of number words that we have to explain is the number of F's is n, where n is a name for an object, namely a number, and F is a word for a concept, like the concept face card or the concept trump or the concept card or whatever it is in the case we're talking about. So numbering, counting, is basically a relationship, he thinks, between a concept and an object. Mm-hmm. So the number of F's is a phrase which takes as its input a concept, F, and produces it as its output, an object, a number.
Right. So the number of cards is 52, the number of suits is 4, the number of decks is 1 or whatever. Okay. So we've got a function that outputs an object. How does that help us understand what this thing is then? Is there anything more to that story?
Yes. Frege thinks that the core principle that we use that explains our grasp of this phrase, the number of F's, is a principle that is nowadays always referred to as Hume's principle, because David Hume mentions it briefly. Hume doesn't do anything with it, he just mentions it very briefly. But the principle is the number of F's equals the number of G's, where F and G are two concepts, if and only if the F's and the G's are equinumerous. So what does equinumerous mean is the obvious next question. And obviously, if I said, well, equinumerous just means having the same number, that'd be hopeless because that goes round in a circle.
Yeah.
The key idea that Frege has is that for two concepts, F and G, you can explain what it is for the two concepts to be equinumerous without using number words in your explanation. Because the idea of equinumerosity is that the F's and the G's are equinumerous if just in case they can be put in one-to-one correspondence. And being put in one-to-one correspondence is a purely logical notion which can be explained either informally or formally using the Begriffsschrift without using number words. So it just means there's a relation that relates F's to G's such that that relation relates each F in its domain to exactly one G in the codomain, and conversely, the inverse relation relates every G in the codomain to exactly one F in the domain. And then if you say, aha, but you use the word one there, so I'm still using a number word. No, you don't need to use a number word there because exactly one there can be explained just in logical terms using identity. So it just means that to say that for each F it's related to exactly one G just means that for any Y and Z, such that Y and Z are both related to X, Y equals Z.
Mm-hmm.
I didn't use a number word in explaining that.
Mm-hmm.
Okay, so that's reduced the whole notion of equinumerosity to logic. So equinumerosity isn't an arithmetical notion, doesn't use numbers, it's a purely logical notion. And then Hume's principle is supposed to relate that purely logical notion of equinumerosity on the right-hand side of Hume's principle to a relation of equality between numbers on the left-hand side.
Okay, right. So let me just try and recap what I'm understanding you saying. So Frege is trying to explain what numbers are in terms that don't involve numbers. And so he hits on this idea of the number of F's.
Sorry, could I just interrupt you?
Yep.
He's not explaining what numbers are, he's explaining whole sentences involving number words. So this is the context principle bit.
Right.
So he doesn't attempt to explain the number of F's on its own. He attempts to explain identities between numerical expressions. Sorry to interrupt.
Yes, no, good clarification. Yeah. So he's starting off with numbers. So the adjectival uses presumably can be reduced to noun uses, which are of the form the number of books on the table is 2, rather than there are 2 books on the table. So we have, and that the number of F's is the concept that you're referring to, that there is no question of the number if you didn't have some concept, that tells you what you're counting. So we're counting that the number of forks on the table is 6, let's say, and the number of knives on the table is 6. And then Hume's principle comes along and says that the number of knives is identical to the number of forks if the number of knives and the number of forks are equinumerous. Okay,
no,
so
not if the numbers are, if the forks and the knives are equinumerous, exactly.
Okay, yes, correct. Yeah, so and that's something to do with, can they be paired up effectively? This is a one-to-one relate. Can they be paired up? If they're paired up, then the knives and forks are equinumerous, which means that the number of knives must be identical to the number of forks. And so we've reduced this idea of number to this idea of equinumerosity, which is a logical idea.
Yes, and you can see that equinumerosity doesn't involve numbering by the fact that if you imagine a big table laid out for a dinner, like a feast in a college hall, you could look down the table and at a glance see that because it was correctly laid, the number of forks was equal to the number of knives. You can do that without counting.
Without knowing the number.
You can see the knives and the forks are paired off one-to-one.
Okay, great. So how does that help us understand the relations between 4 and 5 and things like that for arithmetic?
Well, there's a project going back to the formal stuff where you show how using Hume's, if you just assume Hume's principle is given, you can then use logic to prove various properties of numbers. Now, Frege doesn't carry out that project in Grundlagen, but it can be to a large extent carried out. It's been carried out largely in modern work by the so-called neo-Phrygian logicists who resurrected this bit of Frege's project from the 1980s onwards. Crispin Wright, Bob Hale, largely in St Andrews. The reason that Frege himself didn't quite do it the way that the neo-Phrygians have done it subsequently is that Frege, although he enunciates Hume's principle and recognizes its centrality to explaining our grasp of numbers, Frege himself thought that Hume's principle on its own was inadequate to ground our grasp of numbers. So he thought Hume's principle was important and goes part of the way, but it doesn't, he thought, go the whole way. And this is where we come to the Julius Caesar problem that I mentioned briefly before. So he has this really curious, on the face of it, curious objection, which is, suppose that you accept Hume's principle, and suppose you think Hume's principle gives you, as it were, all you need to know about numbers. But remember, we said earlier, numbers are objects. And the thing about objects is objects form a single logical category. So objects are different from concepts, but objects are one. So objects are one logical category, concepts are another logical category. You might later want to say, actually, concepts are more than one logical category, because you might want to distinguish between first-level concepts and second-level concepts. But let's leave that to one side. So we've got this basic logical distinction between objects and concepts, a distinction, incidentally, which Frege mentions in the preface to Grundlagen as being important. Okay. So objects form this single logical category, and central to our notion of an object, as we were talking about earlier when I was talking about how I grasp the word Nathan, is the notion of identity. That the thing about objects is they're either equal to each other or not equal to each other. So if I am to grasp a name of an object, I have to be able to grasp its identity conditions, what it is for that object to be equal or not equal to an object presented to me in some other way. So as with Nathan, I don't count as grasping the name Nathan unless I understand, in general terms, what a person is, what kind of an object a person is, so that I can track them. At least in principle, I have a notion of what it would be in another setting to meet Nathan again.
Okay. So can I so this is a bit like the idea would be I understand Michael or even the Grundlagen or whatever as a name. If you picked up some object and says, is this Grundlagen or is this Nathan? I should be able to answer yes or no because I know what it would take to be identical to.
Well, in principle, I mean, of course, in practice, I might meet you and not recognize you because you dyed your hair or something. So in practice, there can be problems, but I have a notion of what it would be to meet Nathan again. Even if it's difficult to apply it, I have a conception of people such that it makes sense to ask on another occasion, is that the same person I was talking to before?
Right. Mm-hmm.
Okay, so if numbers are objects, and if Hume's principle is is a complete explanation, is all you need to know what kind of objects numbers are, then it would follow that you should be able to tell, if I give you another object, it should in principle flow from Hume's principle whether that object is equal to a number. Take an object, e.g. Julius Caesar. He just picks Julius Caesar as his example. So is Julius Caesar a number or not? Frege thinks that if Hume's principle is the whole explanation of numbers, and if numbers are objects, then you should be able to tell just from Hume's principle whether Julius Caesar is a number. And he says you can't.
You can't.
So he thinks that's sufficient. The Julius Caesar problem is sufficient to show that Hume's principle is not the whole truth about numbers. There's more to numbers than what's revealed by Hume's principle. So, having treated Hume's principle as a really promising candidate to be his explanation, he then switches to a slightly different explanation, such that he thinks that the number attaching to a concept f is what he calls the extension of the concept of being a concept equinumerous with the concept f. So now the word extension he's using there, we'd normally nowadays call it a set or a class. So the extension of the concept is just the set of all concepts. So his idea is, take an arbitrary concept f, the number of f's is the set of all concepts x, such that x is equinumerous with f. And then the idea is, if you take that as a definition of number, you can then really easily prove Hume's principle as a logical consequence, and then you can, he hopes, do the rest of the formal stuff. You can deliver arithmetical truths as consequences of Hume's principle, but Hume's principle is now just an intermediate step. It's not the whole explanation. The official explanation is that the number of f's is the set of all concepts equinumerous with the concept f.
Right, yeah. And Julius Caesar can't be a number because he's not an extension of a concept.
Exactly.
Right, okay, great. So one little question that's hanging over a little bit from Hume's principle then is, you just for clarification, you'd mentioned that this at least seems to be a candidate for how we grasp numbers. But is by that the idea that we understand what a number is by thinking in terms of equinumerosity, or is that just a way of reducing the idea of number to something else?
That's interesting. I'm not exactly sure what Frege's view about that is. So, I mean, this is an instance of a basic problem about the philosophical project of analysing notions. So, I don't think he's making a claim about how children in practice get taught about number words. That seems to me to be a separate issue. It's more, once a child has, by whatever means, been taught about numbers, has been taught basic arithmetic, has been taught about how to count, you can then ask, now, what kind of grasp have we delivered to the child? So you might put it in terms of, however education is supposed to work at the elementary stage, what do we count as showing that the child has made it? You know, what's the output supposed to be? The output stage is, I think Frege would say, is supposed to be that you don't really know what the phrase the number of f's means unless you, at least implicitly, grasp Hume's principle. you may not articulate it, but
Mm-hmm.
if someone claimed to understand about numbers, but was completely bewildered by the thing we said earlier about the knives and forks in the college hall, wouldn't you say, well, that person doesn't really understand numbering? There's something missing, because you have to grasp. If you understand what numbers are, you must recognize that.
So it's the means. It's a necessary ingredient in the understanding of number, or the grasp of understanding number, even if it wasn't a description of the process by which you came to grasp number. Would that be a fair way of putting it?
Yes. And I think that isn't that fairly typical of a lot of concepts that we have, where how we learn them is one thing, how we would describe our grasp of the concept once we've learnt it might be another thing. An account of our grasp of a concept needn't be the same thing as a genetic account of how we came to grasp it. Those are different issues.
Yeah, for sure. Okay, great. So by the end of this stage, then Frege has argued that arithmetic is good. We have good reasons to think arithmetic is based on logic because of its universal applicability, and that numbers should be considered as objects because adjectival uses can be reduced to that, and that the grasp of number can reduce to logical notions through Hume's principle. And then further, then if we understand it as extensions of concepts, then we can avoid the Julius Caesar problem. Is that kind of where he ends the book then, as saying, sketching out the kind of bones from a philosophical point of view of the plausibility of it?
Yeah, so what's left to do by the end of the book is to have an account of this notion of the extension of a concept, and then using that account to do the formal stuff of showing in detail how you can actually prove that 7 plus 5 equals 12 using this formal definition. He provides a very minimal sketch in the book of how you could get started on that project, but it's pretty minimal. And indeed, on the notion of an extension of a concept, he just says in a tantalizing footnote, I assume it is known. I assume you already know what the extension of a concept. I'm just taking that as assumed here. And of course, what he has in mind is that his next book, The Basic Laws of Arithmetic, first volume of which came out 9 years later in 1893, that's going to be the book where he does all this stuff. There are a lot of promissory notes in Grundlagen where he's saying, this is what I'm going to do. But Grundlagen, we said at the beginning of the talk, of the discussion, was it was to be teed up as a kind of informal taster to get the reader interested, in the hope that the reader would then read Basic Laws of Arithmetic when it finally appeared.
Great.
That's where hard work would come.
And how much do you think Frege has in mind the notion of what we would call a set these days when he's talking about the extension of a concept? How much was that an idea at play when he's saying, I assume we know what it would be?
He doesn't have the modern idea of a set, but that's because the modern idea of a set was developed precisely to deal with Russell's paradox, which is the contradiction which Russell discovered in the account in 1893. So that, of course, is what we may discuss in more detail in a later discussion. But what one can say is Frege just didn't have the modern idea. That's why he fell into the contradiction. But he had part of the modern idea. So his notion of an extension of a concept is a notion of an object which has the feature that you can get it from a concept in such a way that you don't distinguish. It eliminates the distinction between different concepts that have the same things falling under them. If that makes
triangular, and so being triangular and being trilateral
exactly
have the same extension because all triangles are trilaterals.
Exactly.
Okay. All right. Yeah. So sort of a very kind of conceptual idea of that.
Yeah. So the modern notion of a set includes that, but
Yeah.
adds a bit more, a slightly richer structure in order to avoid Russell's paradox.
Yeah. Set membership and rules for construction, etc. Okay. Fantastic. All right. Was there anything you want to add to that, Michael? Or do you think we've
No,
covered grundlagen? That's all good. Okay. Thank you. It sounds good to me as well. All right. Well, thanks very much, Michael. And for anyone listening, as we said, there's going to be a third talk then on Frege where we're going to look at everything after the grundlagen, to recap a lot of his other insights, including the sense reference distinction and Russell's paradox and the results of that. So join us next time. And until then, take care. See ya. Bye.